So what we're going to do is that we're going to do the exact same graph as we did with the T-chart, but we're going to do it using some of these shortcut methods in a three-step process. So step 1, step 2, step 3 are written right here. Just follow the steps and you'll be able to graph any parabola perfectly. So consider f of x equals x squared plus 4x minus 3. The first thing we're going to do is we're going to find the vertex of the graph because it is actually the most important part of the graph. It tells you the turning point, and as we move forward, it's going to have a lot of qualities in real-world problems. Finding the vertex is going to be able to solve. So since we're going to use the formula x equals negative b over 2a, let's start out by identifying what a, b, and c are. So a is the number in front of the x squared, and since there is no number in front of the x squared, we assume there's a 1 there. So the a value is 1, the b value is the 4, and the c value is negative 3. So using the formula x equals negative b over 2a to find the vertex, we'll have negative 4 over 2 times the a value, which is 1. That's negative 4 over 2, which equals, when we simplify, it's negative 2. So the vertex has an x value of negative 2. But we don't know what the y value is yet. So what we have to do is we have to go back to the original problem, and since we know the x value of the vertex is negative 2, we are now going to replace the x with negative 2 in the formula, in the original problem. So we would have negative 2 squared plus 4 times negative 2 minus 3, and solve that. That will give us the y value of the vertex, and we'll be able to graph that point. So negative 2 squared is 4. 4 minus negative 2 is negative 8 minus 3. 4 minus 8 is negative 4 minus 3, which is negative 7. So the y value of the vertex is negative 7. So this is the vertex. We're going to graph negative 2, negative 7, which places it right here. And that's like your starting point. That's the most important part of the parabola. So step 1 is also the longest step. Steps 2 and 3 go fairly quickly. Because step 2, it says graph the y-intercept, which remember is the c value. So when we go back up here to identify what c was negative 3, so the y-intercept is located at negative 3. So on the y-axis, we will place a point at negative 3. And we're done with step 2. And then step 3 is to apply the 1-3-5 rule. We're going to have a modification of the 1-3-5 rule now because we always had a values of 1, whether you recognize it or not, on the previous section. But now we might have a values that are different than 1. But in this case, the a value was 1 because we already identified the a value being 1. So we're going to take the 1-3-5 rule times 1, which means we just still get 1, 3, 5. So remembering the 1-3-5 rule, and if you didn't remember this, you can go back to the start of this video and look at the first 7 minutes of the review. We start at the vertex, and from the vertex we go out 1 both directions and then up 1. The up 1 is the 1 part of the 1-3-5 rule. And then from those 2 points we go out 1 in each direction, but then we go up 3. So we go out 1 and go up 1, 2, 3, place a point there. Then you go out 1 and go up 1, 2, 3, place a point there. But look, they already have a y-intercept there, so that's a really good indication that we're on the right track and that we have the parabola in the right place. And then for the 5 part of the 1-3-5 rule, we go out 1 and go up 1, 2, 3, 4, 5. Go out 1 and go 1, 2, 3, 4, 5. And then there's the third points, and then we make our parabola. So if you want to compare that to what we already did, so there's what we just made, and then go back to the original problem where we did the T-chart. They are the exact same parabola. I didn't extend it as high as I did the other one, but they are the exact same because the exact same vertex. The turning point on both of them was at negative 2, 7. You can see that the vertex down here was at negative 2, 7 using the T-chart. And we have the exact same parabola. And we should have done it in a much faster way than using the T-chart. Here's one more example. So consider f of x equals negative 5x squared minus 10x plus 6. We're going to graph that as well. So again, step one is find the vertex using, and then what's that formula? That formula is x equals negative b over 2a. So let's identify a, b, and c. So a is, this time we do have a number in front of the x squared. It's negative 5, so a is negative 5. B is negative 10, and c will be positive 6. So using the formula x equals negative b over 2a, since the b value is negative 10, we'll have negative 10, which will turn into a positive 10 on the next step, over 2 times negative 5. So negative 10 is the same as positive 10 over negative 10, which is negative 1. So the x value of the vertex is located at negative 1. And then we've got to plug that back in to find the y value. So I'll go and change the f of x to a y because it means the same thing. So y is going to equal negative 5 times negative 1 squared. So again, I'm replacing the x's with the negative 1 that I just found, minus 10 times negative 1 plus 6. So when you do negative 5 times negative 1 squared, we got to follow order of operations, which means we're going to do negative 1 squared first and then take that times negative 5. Remember GEMDAS, the exponents come before multiplication. So negative 1 squared is positive 1, and then that positive 1 times negative 5 is negative 5. Negative 10 times 1 is positive 10 plus 6. And then we add those together. Negative 5 plus 10 is positive 5 plus 6, which means we have a y value of our vertex at 11. So the vertex is located at negative 1, 11, which is a little bit off our graph, but it's not far off, so that's not going to be a big issue. So there's negative 1, 11. They're at a little bit higher than my graph runs. So we got step 1 done, and then we have a much quicker step 2 and 3. So step 2 is graph the y-intercept, which is the c value. And remember, the c value was 6, so the y-intercept is 6. So I'll place a point up here at 6. And then we're going to apply the 1, 3, 5 rule, but this time there is an adjustment for the a value because the a value is negative 5. So using the 1, 3, 5 rule, I'm going to take all those values times negative 5. So 1 times negative 5 is negative 5. 3 times negative 5 is negative 15. And 5 times negative 5 is negative 25. So instead of going up 1, up 3, up 5, we're now going to go down 5 since it's a negative 5, and then down 15, and then if we have room, go down 25. But I think you're going to discover we're going to run out of room pretty quickly here. So again, starting from the vertex, we'll go out 1 both directions, but then we're going down 5. So down 5. So out 1 and go down 1, 2, 3, 4, 5. Place a point there. Then you go out 1 and go down 1, 2, 3, 4, 5. And then we would place a point there, but there's my y-intercept, so that's a pretty good indication that we're on the right track. But now we're going to go out 1 and down 15 on both directions. So out 1 and then down 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then out 1 and down the same 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right there. And then if we have room, we would go down 25, but that's actually going to go way off my screen, so I'm not going to do that. I think we got a good indication what the graph looks like. And it is very tall and very skinny because it got stretched by that a value of negative 5.